Hi, I'm Beth Wilson. I'm one of the hosts of STEM in 30, a television program for middle school students produced by the National Air and Space Museum. This month marks the 20th anniversary of continuing human presence on the International Space Station. We are supposed to be joined by NASA astronaut Chell Lindgren, who spent 6 months aboard the 6 months aboard the station and is originally from the DC area. He graduated from Robinson Secondary School, and we know we have a lot of Fairfax County students watching today. Chell is currently working as crew support for the Dragon Crew SpaceX 1 mission that is supposed to launch on Saturday. The Crew 1 flight will carry NASA astronauts, Crew Dragon Commander Michael Hopkins, pilot Victor Glover, mission specialist Shannon Walker, the Japan Aerospace Exploration Agency mission specialist Soichi Nogichi, and they are all going to the International Space Station for 6 months. Unfortunately, because of this important work that Chell is doing with this mission, he is unable to join us today. He's actually doing a dress rehearsal for Saturday's launch. We will try and have him join us in the future for another one of these live chats. We know that it stinks not having a live astronaut today, but we will be hearing from several other astronauts throughout the show. In the meantime, we are very fortunate that Dr. Jennifer Levasseur, who is a space history curator at the museum, is with us today. And Jennifer, let's just get started. Can you tell us why the International Space Station is so important? And we'll be joining, and we'll be taking your live questions as well.
So thanks, Beth. And I apologize to everyone that was expecting an astronaut. I'm not exactly the most exciting of backup plans. But Beth speaks the truth when she says Chell is a fantastic friend of STEM in 30 and the National Air and Space Museum. So we really regret that didn't work out for today. But what he would tell you is, and there he is in person in the museum exhibition that we did on this era of human spaceflight. And so I want to sort of tell a little bit about what the International Space Station is important for in the context of human spaceflight. This is really, the space station is really the ultimate goal and what we've been looking towards achieving for the last 60 years. And that's the ability to live in space for long periods of time. While most astronauts don't spend more than about 5 or 6 months on the International Space Station, it is all about the knowledge that we're gaining from those missions that's going to help us go to other places. Because missions to places like the moon and Mars to really be beneficial need to last months and months. And in some cases, in the case of Mars, they need to last for years. And so knowing what space does to the human body, that's a really important role of what's happening, sort of what the astronauts are doing. Their job is basically to help us learn more about what happens to them in space. They're kind of test subjects for all of these missions that we look at in terms of going forward and going to other places. So it's they're kind of, like I said, guinea pigs in a sense for all of us. And so over the last 20 years now, we've had these people going up and being voluntary guinea pigs for our experiment that continues to be living in space.
We will be taking your questions live still. Jennifer is very knowledgeable, although she has not done a spacewalk, but we will cover that from some other astronauts that we have previously spoken to. So put your questions in the comment section. Let us know where you're watching from, and we'll give you a shout out. Now, as we said, we have worked with Chell before, and so we want to take a very quick look at a video that he did with an experiment with marshmallow bunnies.
We're joined by NASA astronaut Chell Lindgren. Chell, thanks for joining us.
Oh, my pleasure. I'm excited to be here.
You've done a couple of spacewalks. What's that like?
Oh, it is absolutely amazing to put that big white spacesuit on and to go outside to go outside into the vacuum of space, to do real work, to do repairs on the outside of the space station. And we're separated from that vacuum of space by just this thin layer of plastic, but it occupies your whole field of view. So when you go outside, you're able to see the outside of the space station, to see the Earth below and the thin layer of atmosphere so clearly through that thin piece of plastic.
Now, you're also a medical doctor.
That's right.
So you understand what would happen if you went out without the suit.
Yes, and it would be bad.
Okay, well, we're going to do a little science here about
All right.
not having a suit. Now, there's nothing I like more than creating a vacuum chamber with an astronaut. So I'm going to put the bell jar on top,
Okay.
and I'm going to ask you to turn on
All
the pump,
right.
and we're going to watch what happens to these marshmallow bunnies.
Here we go.
So right now we're sucking all of the air out of there, and look what's going on. Wow.
Okay, you want to turn that off?
Okay, you bet.
Now watch what happens. Chell, do you want to tell us what's going on here?
Wow. So we are all surrounded by essentially the weight of the atmosphere, and it's what we call pressure. The pressure of the sea level pressure where we're at right now, and pressure is pushing down on those bunnies in kind of the normal state. Now, when you start to take the air away, you did it in the vacuum chamber there, and then that's what is outside of the space station. As you take that air away, there are little air pockets, little air bubbles all spread throughout that marshmallow. And as you take the outside pressure, that outside weight of the atmosphere away, those little air bubbles on the inside start to expand, and it carries the marshmallow with it. So those bunnies start to grow.
Now, is this what would happen to you all without a spacesuit on?
Well, we're not made out of marshmallow.
Okay.
I know that. So not exactly, but there are some things that we would be very concerned about. One, again, the lack of air to breathe, and the absence of pressure would actually pull air out of our lungs, and any small air pockets within our skin and our body, that air would expand. And so even with your skin, if you pushed on your skin would bubble up a little bit, and you could feel it would feel like Rice Krispies underneath your skin. It's called crepitus, and I think my friend Jack Fisher was here not too long ago, and you all demonstrated what would happen if to water or to a liquid when exposed to vacuum, and it starts to boil. Again, the lack of pressure causes that to boil, and unfortunately that's what would happen within our bodies as well, is that any of the fluids that are exposed to that vacuum would start to boil off.
Wow.
Not a good situation.
Yeah, well, it was kind of a bad day for the bunnies.
They still taste good though.
Sure. Yeah, I like any science that I can eat.
Chell, thanks for talking about this.
Oh, my pleasure. Thank you.
And we're hoping to have Chell on very soon because he's such a good sport. We've got a lot of people watching from South Dakota, Bull Run Elementary School, Italy, the Philippines, Mexico, Glasgow, Scotland, Germany, Washington, Navarra Middle School, Chicago, Indiana, Oklahoma, North Carolina, and the Dixon family would like a shout out. So hello to the Dixons. Now, we'll start with a question that was submitted earlier. And our first question that we have is, what do you eat and drink in space? And that's from Ms. Z's class at Providence Elementary School. So we'll go over to Serena Chancellor-Agnon, and she answered this question actually while she was in space.
So this is really neat. I had to learn how to eat up here when I first got up here, but you got to look at what happens to fluids. Nothing really pours up here. So I can open a special packet of soup, and that soup isn't going anywhere. It doesn't spill out. It sticks to the surface, and it sticks to each other, and that's because of something called surface tension. This is a drink bag, and it's filled with raspberry lemonade, and I'm going to show you what happens when I open this valve. It doesn't come pouring out. Just watch. That bubble will keep getting bigger and bigger and bigger. I'm going to make it kind of big, and then watch what happens when I stick my hand to it. See how it just sticks to my hand? It just waves there. It doesn't really go anywhere. It just sticks right to the surface, so I could drink my lemonade right from my hand.
That looks like a fun way to eat and drink, just sort of letting it float around. I always thought that it'd be like being a goldfish, and swimming up and just. Jennifer, this is a question we often ask astronauts, but I'm going to ask you because you have a lot of knowledge on this and you are a historian and you collect for the museum. And so Bryce would like to know, what is your favorite mission?
Oh, great question. So I have some really fond memories because I'm probably a little bit older than Bryce, I suspect. But when I was growing up, I was fascinated by the space shuttle. And I used to watch space shuttle launches all the time on television because they were pretty much always live on TV, as we're going to see this weekend with the SpaceX Crew 1 Dragon launch. So my favorite mission, I have two actually. One of them is the launch that I actually skipped school to go and watch. So when I was a college student, I left my class to go and watch John Glenn launch on his space shuttle mission back in 1998. It was amazing, not just because it was an American hero going back to space and an astronaut who I grew up watching because I lived in Michigan and he was the senator from Ohio. So I knew exactly who he was my whole life. But also because I wasn't the only person there. There were 200 other people sitting around watching it in the student union that day when I went in to watch it. And so it was a really interesting community experience. And then, of course, my absolute favorite launch is the launch that brought Discovery back to Earth. Because I'm the curator for the Space Shuttle Discovery. So STS-133 was Discovery's last launch into space. And so I wouldn't have a space shuttle curate if that didn't come back safely. So I have to say that's my other one. I did go to the STS-131 launch and see Discovery as well. So those are just a few of them. But I am more excited than ever to watch more of these crew launches that SpaceX is doing these days. It's an incredibly exciting time. And for a lot of young people, this is your space program now. It's not mine anymore because that was the shuttle program for me as a kid. But now you're getting to see what spaceflight is like.
Yeah, and we watched that last launch of Discovery from the museum too, and that was really incredible to have these screens all out through the museum and all the visitors stopped and watched. They really are amazing. So I think everyone should, mark your calendars, keep updating for Saturday because that's going to be a really exciting launch as well. We have the next question is from Ms. Grandin's class. And they want to know, is it scary looking down from space? And we have astronaut Nick Hague that answered that for us.
There's this distinct memory from my last spacewalk when I was out on the front of the space station out on Node 2. We had been installing a docking adapter and we were cleaning up and the sun had just risen and the earth had just lit up below us and I so comfortable in the suit at that point, it being like my third spacewalk, that the suit just kind of melted away and I took 30 seconds to just look out at the earth and see it glide below with nothing between me and the earth riding on the station. And that's a memory that I'm going to remember distinctly for the rest of my life.
I want to let everybody also know that Jack Fisher did another Smithsonian Science Starter, and we'll put that link in the comment section. And he had a really great description of his spacewalk as being like when you go on vacation and you're in the hotel room and you look out over the ocean, it's beautiful. But then when you go outside, it's totally different. So he gives a really good description as well. Jennifer, we have the next question is, how long does it take to get to space? And I think this is kind of a three-parter. If you could answer, how long does it take to get to the International Space Station, the moon, and then maybe if you even want to address Mars.
Yeah, for sure. So it is different. You've got a lot farther to go, obviously, if you're going to the moon or Mars. So, and it also depends on what kind of spacecraft you're in. So we saw an image at some point earlier, which was the International Space Station. To get to the International Space Station is dependent on which vehicle you are in. So when the space station was being assembled, the space shuttle would launch and take up parts of the International Space Station to attach. And it usually took them well over a day to get there. Upwards of 2 days, because the size of the spacecraft, the cargo, the weight of the vehicle, it took a little bit longer than you might expect to actually get all the way there. They're at 225, 250 miles up. And the way the orbital mechanics work, you have to kind of slow yourself down to get to it. It's a very complicated process. Now, if you were to ride on, say, a Crew Dragon, or you were riding on a Soyuz, it would take you a lot less time. It's a lot smaller vehicle, and it doesn't take nearly as long to get there. And there's a long process with finally actually getting yourself so that you can open that hatch and go out into the space station as well. So it takes a little bit longer. That's not something that tends to happen just within a few hours. It takes some time. But when we're going to a place like the moon, and the Apollo astronauts had that experience, when we go back to the moon, it will work in a fairly similar fashion, which is you launch into orbit. There is a very short orbit that happens, and then there needs to be a boost, basically, to exit Earth's magnetic pull and get yourself on the path to the moon. This is called translunar injection. It is what all the Apollo astronauts who went to the moon had to do and experience. So you turn your rocket engines on and you blast towards the moon. And then that journey of 240,000 miles takes about 2.5 days. Or 3.5, up to, I think it's more like 3 days, actually. And so the astronauts spend a lot of time in transit. They're able to do a lot of photography, as we know, and prepare themselves for entering the moon's gravity and lunar orbit. But when we go to Mars, it's a totally different story. We're not talking about days, hours, anything like that. We're talking about months. So the journey is a very slow journey. If you follow the paths of any of the the Mars rovers that have gone, you're talking about usually 9 months or so to get to Mars. And so it's a much longer journey. But then once we get there, we actually have some setting up to do. So an entire round trip from getting to the surface of Mars or to the orbit of Mars, setting up some kind of a base camp on the surface, and then being able to do work there and then return makes it probably about a 3-year journey. And that is no small thing to think about. You probably, can equate it to some of the things you've seen in science fiction before, and they're not that far off. The science behind a movie like The Martian is fairly accurate in terms of the journey time, the challenges that we would experience upon getting there, and then obviously some of the things that would be incredibly difficult to manage if there were a problem. And so figuring out how to tackle challenges is a big part of how we'll understand a little bit better about how to spend time at Mars rather than just get there. I think it's not the getting there that's so much the problem, it's the staying there. Because what happens if something goes wrong, and you need to make sure you have the right tools for all of that. So each of those presents its own set of challenges and risks, certainly, too.
We have a lot of schools watching from all over. Camelot Elementary, 6th grade is watching. Jonesville Elementary School is watching. Oak Grove Elementary, a group of homeschoolers in Wisconsin, Center Ridge Elementary School, Rolling Valley Elementary School, New Prospect Elementary, Rolling Valley Elementary, Holland Meadows Elementary School in Alexandria, Parsons Academy for Girls in North Carolina, and Springfield Estates Elementary School. Thank you all so much for watching. Yeah. We hope you're getting a lot out of it, even though Chell is off doing some other very important work. Mrs. Carlson's class wants to know how you talk in space, and English teacher Mrs. Jeffers is curious to know how much do you rely on your writing skills as an astronaut. Now, we have Victor Glover actually answering these questions. He is launching on Saturday, so pay very careful attention to who Victor Glover is.
One of the things you learn working around a bunch of engineers is how important it is to be able to communicate. You could have the greatest design. This is going to solve these amazing problems, but if you can't communicate that, you may be the designer, but the folks who have to build it need to understand what's in your head. And that's what communication is, taking something that resides up here and getting it to reside up here in someone else. So it's extremely important to be able to communicate. And just like you practice football, just like you draft and you practice math and you practice computer programming, you have to do it in order to do it well. Communication, written and verbal, are things that you have to practice as well.
The next question we have is from a 9-year-old, and Jennifer, he would like to know, why don't we send astronauts to the moon anymore?
Great question. So there are a few different reasons for that, and I'll try to keep my answer kind of simple because it is a very complex answer. So in the 1960s, when we were planning on the voyages to the moon, there was what we call the space race between the United States and the Soviet Union. And it was this partly political effort, basically, to reach that particular goal of getting to the moon first as sort of that end point. And we were challenging each other as countries to achieve that. Once that was achieved by the United States, the popularity and interest in going back to the moon declined in the United States fairly quickly. And it declined in terms of the politics as well. So there wasn't really the same kind of support for continuing that effort. In fact, some later Apollo missions that would have carried the program into 1973 were canceled because funding was cut to NASA for those. So why aren't we doing it? Why haven't we done it since then? There's just not really the same motivation. There's plenty of interest in the moon on the parts of scientists, but we've been sending all kinds of probes to the moon for a long time. We've been studying the moon from vehicles like the Lunar Reconnaissance Orbiter, which can map the moon. And so scientists, even at the Smithsonian's National Air and Space Museum, are studying the moon today to learn more about it. But what could we get out of going to the moon in person? Well, as any of you who know anything about robotics will be able to tell the rest of us, robots are not the speediest of things out there. Humans can still function much faster. And so if we put people on the moon or even on Mars, our ability to gather information and process it will be exponentially higher than the speed at which we learn from robots and the information they can gather. So the idea is, for scientific reasons and for lots of reasons in terms of maybe even economics, there are some really compelling reasons to go back to the moon and figure out just what can we get from the moon, what can we learn about the moon, what does learning about the moon teach us about the origins of the Earth as well, because most anything that we learn in space then kind of can be reflected back on exactly what is going on in the Earth. So we often look at these, scientists often look at it in reverse, which is we can study features and forms on Earth to understand the moon and Mars better. So you can do that in reverse as well. And it just happens a heck of a lot faster with people there.
That's a long answer, but I'd like to go to the moon. It's very complicated.
It is.
Mrs. Lininger's class would like to know if anyone ever got injured in space. But Jennifer, I'm going to expand on that a little bit. Astronauts really have to work out when they're in space. Can you tell us a little bit about the importance of working out?
Yeah, so when a human body is in space, there's no gravity to really tax the muscles and the skeleton like we are taxed, just even moving around and kind of bearing our own weight here on Earth. So you have to find ways to do that. And the best way to do that in space is to exercise. So if you can think about all of the just movement, the simple movement you do throughout the day, astronauts need to do that on a treadmill or on a weightlifting machine or on their version of a bicycle. They need to recreate that effort that your body naturally goes through in space to be able to maintain their muscles and their bones and the rest of their systems, because their heart isn't taxed the same way. So to maintain your body, you really have to exercise. And usually it's for 2 to 2.5 hours a day. It's no small feat. I go to the gym and I get a 50 or 55 minute workout in. That gets my heart going. It's exciting. You know, it really makes me feel good. But astronauts astronauts need to more than double that to be able to just maintain normal sort of body composition and health. But in terms of, has anybody ever been injured in space? I can say this, there's always a medical kit nearby. There are lots of tools available if there was an injury, and there are always people looking to see what would happen if there were a major injury. There have never been any major injuries. I once heard one of the other doctor astronauts years ago at a museum talk say the worst thing he ever had to manage in space as a medical doctor was a paper cut. And so thanks to Dan Barry for feeding me that value years ago. But I think other than things like compensating for some of the things that happen in that kind of environment, so you might get a headache. Maybe the air is a little more carbon dioxide heavy one day rather than another. They might need to take something to help them with that. They might be fatigued. They might not feel well. They get the same kinds of problems in space that we get on Earth. You know, they have an upset stomach. There's things to take care of that. So there are always tools available, including things like if they did have a major cut, like they hit their head on something, there's always a way to stitch that up.
Well, astronaut Mark Vande Hei had some opinions on where he liked to work out.
I like Earth gravity for working out. It's, I don't know if it's the isolation of being on the space station or just the slight difference, or that it takes a while to get comfortable working out in space, at least it did for me. And it's easier to work out on the ground, because maybe it's because it's something we're used to, but I certainly like being back on the planet.
So, Jennifer, the next question is for you. And Sela, who is 6, would like to know, typically, how long do astronauts stay in space?
So the time astronauts spend in space has gone up dramatically over the course of our time in space generally as humans. So back in the early days, the very first American in space was only up there for 15 minutes. Now we're at a point with the International Space Station where astronauts can stay for months and months and months. So the record stay in space was actually accomplished on the space station Mir, which was the Russian space station, that was in space just before the International Space Station. And one of the cosmonauts stayed up there for over 400 days.
Wow.
So that's an incredible length of time, over a year in space. And now on the International Space Station, we have the record with the Year in Space program, which went on about 5 years ago, where Scott Kelly and his Russian counterpart stayed on the station for just shy of a year. So they've got the record for the International Space Station. Most astronauts are designated to be up there for about 5 months. Many of those have been pushed a little bit longer. So some of the astronauts who were up there who launched in 2019 ended up staying for about 9 months. So a little bit longer than was expected, but there are always resupply ships that can help keep them flush with food supplies and other kinds of necessities that they need. So they get regular shipments of goods, fresh food, things like that. So they're able to stay in space longer.
We, again, have a lot of people watching from Argentina, Italy, India, Mexico, Ecuador, Brazil, Pennsylvania, Delaware, Burke, Virginia. And we've got a lot of schools watching, too. We've got some Nashville homeschoolers, Little Run Elementary, Kennedy Academy in South Bend, Little Bennett Elementary School, homeschoolers in Delaware, Sangester Elementary, Southwick Elementary School, Mrs. Graney's class. Thanks for watching, Mrs. Graney. And Elkhart Middle School. For those of you who are just joining us and who were expecting to see NASA astronaut Chell Lindgren, he is doing a very important job. He's doing a dress rehearsal for Saturday's launch of SpaceX. And could not join us today. I know he really loves working with us. So I know it's whatever he's doing is very important because he loves talking to you all as well. We have The next question, Lillian from Alaska and Spring Hill Elementary in McLean want to know, how do the astronauts go to the bathroom while they are in space? Well, Mark Vandehei has the greatest answer, so let's go back to Mark.
In space, the idea of a floater can take on a different meaning. Gosh. So you can imagine using the toilet up in space we use airflow instead of water flow to get rid of human waste. So suction is important. And for me, as a first-time flyer getting to the space station, I kind of felt like I needed more flow, if you can imagine what I'm talking about. It was a little unsettling not knowing what was going on behind me as I had my first experience with the toilet. It all worked out well, but there was definitely a floater one day. I'll just leave it at that.
Sorry. They've always had problems with that from Apollo onward.
Yeah, that's for sure.
So it is not an easy process to go to the bathroom in space.
It is not. We should all be thankful for gravity in that.
So on December 3rd, we will be hosting an ISS downlink with Victor Glover, who hopefully they're all ready to go on Saturday. Things can always change with weather and that. Jennifer, can you tell us what is a downlink and how does that work?
So one of the probably coolest things about how the International Space Station is developed is how the communications tools that we have here on the ground that make these kinds of events possible are also available on the International Space Station. So a few years ago, I looked into this and I was particularly interested in the Wi-Fi capabilities on the space station. And so that capability came around a little bit later. So that's one of the things to think about when you're talking about space and technology as of the ground going to space is we have to be really, really sure they work well and that they're safe for going up to space because that environment is so different. So they got Wi-Fi probably a lot later than most homes that have Wi-Fi now. So they have connectivity, they have Wi-Fi connectivity up there, but their ability to downlink, so to actually have like a live phone call with or a live video link is really about speed, just like it's about speed for us to be able to have these kinds of internet communications. Speed is important there too, because there is a fairly large distance. It's 250 miles, but you're going through the atmosphere. So there's, it takes a bit more effort and it takes some pretty strong technology and some capabilities to be able to do that. But it is possible, and this is really important for the lives of the astronauts, it is possible for them to literally pick up an internet phone. So they could pick up their laptops and they could make a video phone call to their families on the ground. And those are scheduled regularly so that they can see their families. So they're doing Zoom calls from space all the time, maybe not Zoom, but they're doing some kind of video conference chat, not only with their families, but with doctors and others on the ground that they need to talk to for various reasons about their work or about their health. So the downlinks happen all the time. It's just that we get this really special window where we get to host that downlink information. So, we get to ask that person live exactly what's going on up there, which is really exciting.
Yeah, so everybody mark your calendars, keep checking our social media. We don't have a time yet because it actually depends on where the International Space Station is, because we only get about 20 minutes with them before they sort of fly out of range. So we do have it scheduled right now for December 3rd. It'll be a lot of fun, so be sure to check that out. Our next question is, have you ever failed at anything? And Kate Rubens, who is currently on the space station, is going to answer that for us.
So I have definitely experienced failure. I would say as a scientist and a researcher, you actually have a lot more failures in your experiment than you have success. And that's the process of science, is that you've got a question, You don't necessarily know the answer, but you set up your experiment to look at what the answer is going to be. And since you don't know how to get to that answer, your experiment may fail a few times. We actually expect the experiments in our lab to fail maybe 10 or 12 times before they work. Sometimes when those experiments are failing, we actually learn a lot of new and interesting things. So when you're failing in a scientific investigation, sometimes you're actually succeeding more than you would think because you can learn something new.
The next question we have, and it's a two-part question for you, Jennifer. Devontae from Mrs. Gates' class wants to know, where do you get your suits? And Camelot Elementary School wants to know, what are the most important parts of the astronauts' suits? Now, we have a lot of suits in our collection, but there's one that you're particularly missing right now.
Yeah, absolutely. So thanks, Devontae, for that great question about spacesuits. While I am not the spacesuit curator and expert at the museum, I do spend lots of time thinking about astronauts and spacesuits, because you have to think of a spacesuit like a little spacecraft. You have to have all of your support equipment in that suit or attached to that suit, because you have to go outside into that vacuum, like Chell was mentioning earlier, when you go on a spacewalk. You have to be protected from that environment, just like normally the space station protects you when you're inside. So we do have one large missing gap in our spacesuit collection, which is the suit that you see on screen. Now, this is the same suit. These are the same pieces of spacesuits that were developed at the beginning of the space shuttle program. So we're talking things that are 30 years old, 40 years old at this point, really. So many of these parts, the parts that are qualified for flight, were developed back in the late 70s and early 80s for astronauts to use on spacewalks. But NASA has been continuing to reuse those parts over and over and over and make modifications to them and to test out new kinds of gloves and things. So we do have gloves in our collection, gloves that were flown in space, but we don't have a full suit like you see in this picture here. So what we've asked NASA to do is, because this is really an iconic thing about the last 40 years of human space flight, this spacesuit itself, we've asked NASA to basically, at the end of the use of all of those spacesuits, save one, put together one, so that the National Air and Space Museum can show visitors exactly what that suit looked like. And so when we get that on display as part of an exhibit coming in a few years, it will be a really special and unique, talk about a unique thing. It will be the only one that is all flown parts that someone could literally just kind of step into. We won't obviously be able to do that. We'll want to protect it because it will be the only one on Earth. We're really looking forward to having the opportunity to show that, and also to show it as a part of our entire collection, because we have suits going all the way back to Alan Shepard's suit that he flew on his Mercury mission. And so being able to look at the technology and how it's developed over time is a fantastic part of what we're able to do at the museum.
Now, you mentioned a new exhibit that we're building. Do you want to touch briefly on what we're working on? Because the Downtown Museum, as many people know, is under construction, and you are working on a pretty important exhibit.
Yeah, so right now we have an exhibition, and you've seen all of the astronauts basically talking on the stage in our Moving Beyond Earth exhibition. So all those clips you've been seeing, they're standing on a stage in that exhibit. We're going to take that exhibit and really expand on what we know is the major story of the last, what will then be 25 years of human spaceflight. So right now we're in 2020. We've celebrated the 20th anniversary of the International Space Station. In 5 years, when this exhibit opens, we'll celebrate 25 years of the International Space Station. And so we're going to talk about how we constructed the space station, what the space shuttle was used for. So we know that it was used to construct the International Space Station and really get us ready for life aboard the space station. We did lots of science on the shuttle, lots of engineering. But we want to show you what it looks like now. So we're going to be able to have a space that looks like the Destiny module on the ISS. You can see in this picture, you'll be able to walk through that module and see what it looks like for astronauts. And a lot of the recordings you see and the downlinks you see, and probably with Vic Glover as well, are from this space. So it's really an identifiable space, but it's the primary location for astronaut science. And so we're going to focus on space science. The science astronauts are doing all of the time. That's 50% of their time in space. But it's on the Destiny Lab. And so this is the Destiny Lab being delivered by the space shuttle. We want to focus on that. And we want to talk, obviously, a lot about what it's like to live in space. So they live inside this really small space, but they do lots of work to maintain the shuttle, maintain the station through doing spacewalks like you see on the left. On the right, you can see Sunny Williams, who gave a lecture for us just a few nights ago, doing all that exercise. It's an intense part of their day. It is very scheduled. Their days are planned out well in advance. They need to know what they're going to be doing, and exercise is a huge part of that. So we want to expand on that and show you what life is like, but also what they get to do in their downtime, because they want to make this space a home. As many, many, many of you all probably realize by now, spending your work day or your school day in your home isn't all that different in a sense from what the astronauts do, because the space station is their home. And so we call this exhibition At Home in Space, because they do some of the same things you do. And I can tell you that this picture right here happens in my home more often than us watching The Last Jedi. It's not an uncommon experience in this house. And so I can really identify with the astronauts wanting to really enjoy something like a movie. And so they've set up their own spaces for that, their own experiences, and they get to do it together. We also want to tell you, obviously, about what it's like to look at Earth. And so we have this media window going in the floor. Well, you'll be able to see, just like astronauts see in one of our earlier questions, you'll get to see what it looks like from the space station. And you'll get to see the outside of the station too with our big, large scale model. And so some of it is about what we've done up to this point, and then it's what's going to go from what we're going to be doing from here on out. So it's not just about what we've learned to this point. It's talking about the experiments that are ongoing and things that'll teach us about doing new things in space. So we're going to have in our exhibition one of these spheres, these little round balls. They look about the size of a basketball. Those are an experiment to kind of think about how we might use robots to function as assistants, or to be able to learn more about propulsion. So these use tiny little gas jets basically to propel themselves around. And Drew Morgan here was experimenting with those on his mission last year. And astronauts continue to do that. But what are we really aiming towards? It's not just about living in low Earth orbit. It's about going farther. And we're getting ready to do that with the Artemis missions. And so this is a fairly recent photo of Artemis 1 ready on top of its service module. It will be eventually mounted to its rocket, the SLS rocket, which will launch it into space sometime in the next 18 months or so. And it will head towards the moon and come back. And that capsule we hope to have in the exhibition if everything goes according to schedule and plan. And that will be the predecessor to Artemis 2. And the Artemis 2 mission will be the first to land astronauts back on the moon since 1972. So we're telling that story about not only what's happening today, but what's happening next. And it's really a great sort of comprehensive story of the bulk of our human spaceflight experience. We talk about Apollo and Gemini and Mercury as these really heroic moments, and that they are, there's no doubt about it. But most of our spaceflight experience is on the space shuttle and everything that we've done in the last 40 years now. So this is really where we've learned how to do it and how to keep it going.
I'm really looking forward to seeing all of these new exhibits. I hope that everybody who's watching is able to make it out. We have run out of time for today. And again, for those of you who had expected to see Chell, Jennifer, you did a great job. Thank you so much for pinch hitting. Chell, again, is doing some very important work getting ready for Saturday's launch. I wanted to address one question from Milton, who wants to know, when are they going to have house cats on the International Space Station? Cats are ideally suited for apartment dwellings. Well, Milton, I've got my space castronaut back here. So they're not going to the ISS, they're going to Mars. We want to let you all know that we have another live chat about the Science on Station next Thursday, November 19th. Again, we have our downlink with Victor Glover on December 3rd. We have some naval aviation programs coming up in December, our STEM 30, and then we will be doing a live chat with the Blue Angels on December 10th, and looking at their newest plane, Fat Albert, in the coming weeks. So again, we want to thank you all for joining us. And we want to thank Chell for doing the tech test and being ready. But, things happen. So please keep an eye out for our next live chat with an astronaut. And thanks so much for joining us today.
Thank you.